Welcome to Pharmacology Insights, where we break down complex pharmacology into simple, easy-to-understand concepts. Antipsychotic medications, especially second-generation or atypical ones, like Olanzapine, risperidone, and clozapine are well known for causing weight gain. Today, we're breaking down the science behind this common and often frustrating side effect. From dopamine and serotonin to histamine and acetylcholine, let's unpack how these drugs add on the pounds. Antipsychotics are primarily used to treat schizophrenia, bipolar disorder, and psychosis. They work by blocking dopamine D2 receptors in the brain, especially in the mesolimbic pathway, to reduce hallucinations and delusions. Second generations, or atypical antipsychotics, also block serotonin 5-HT2A receptors, which helps rebalance dopamine in other brain regions, and reduces the risk of motor side effects like tremors or rigidity. But these effects are just part of the picture. These drugs don't act only on D2 and 5-HT2A receptors. They also interact with other receptors in the brain that regulate appetite, metabolism, and energy levels, including serotonin 5-HT2C, histamine H1, and muscarinic M3. They can even interfere with hormones like insulin, leptin, and AMPK. Let's look at how each of these mechanisms contributes to weight gain. Blocking D2 receptors in the mesolimbic pathway reduces psychotic symptoms. However, these drugs also block D2 receptors in the hypothalamus and reward circuits, areas involved in motivation, pleasure, and feeding behavior. With dopamine activity in the brain's reward system reduced, food feels less satisfying. People may compensate by eating more, especially reaching for high-calorie comfort food, in an attempt to regain that feeling of reward or satisfaction. The serotonin 5-HT2C receptor helps regulate satiety, the feeling of fullness after eating. It plays a key role in appetite control in the hypothalamus. When antipsychotic drugs like olanzapine or clozapine block these receptors, the fullness signal weakens. The result? Increased appetite and more frequent eating. Antipsychotics also strongly block histamine H1 receptors in the hypothalamus, the brain's appetite command center. This blockade can stimulate appetite, making you feel hungrier, and thus increasing your food intake. Another lesser-known but important player is the muscarinic M3 receptor. These receptors are found on pancreatic beta cells, where they help regulate insulin secretion. Antipsychotics can block these receptors. Blocking them can impair the body's ability to release insulin in response to glucose, leading to higher blood sugar, insulin resistance, and increased fat storage, all of which contribute to weight gain. There may also be effects on the M3 receptors in the brain, potentially disrupting metabolic regulation, though this is less well understood. But the story doesn't end with the neurotransmitter receptors. Antipsychotics can also mess with your body's metabolic hormones, making weight gain ever harder to prevent. Let's start with leptin, the hormone that tells your brain, "I'm full, stop eating." Some antipsychotics may interfere with signaling, so the brain doesn't get the full message clearly. The result? Continued eating despite adequate food intake. Next is insulin, the hormone that helps move sugar out of your blood and into your cells. Some antipsychotics reduce insulin sensitivity, which means more sugar stays in your bloodstream and more of it gets stored as fat. And finally, AMPK, or AMP-activated protein kinase. In the hypothalamus, AMPK acts like a fuel sensor. When energy is low, AMPK is activated, promoting hunger and fat storage. Antipsychotics can increase AMPK activity in the brain, even in the absence of true energy shortage. This tricks the brain into thinking it's in a low energy state, leading to increased appetite and more fat storage. So, do all antipsychotics cause weight gain? Not to the same degree. The risk of weight gain depends largely on how strongly each drug binds to the 5-HT2C, H1 and M3 receptors. Here's a simplified comparison. In summary, antipsychotic-induced weight gain results from a combination of several factors. Dopamine D2 blockade reduces reward and motivation, 5-HT2C blockade weakens satiety signals, H1 blockade increases hunger, and M3 blockade impairs insulin response. Additionally, there could be hormonal or metabolic shifts that cause leptin dysfunction, insulin resistance, and AMPK activation. Understanding these mechanisms helps clinicians predict side effects and may one day help support the development of safer, more targeted treatments. And that's it for today's pharmacology video. If you enjoyed this video, please give it a thumbs up and subscribe to the channel for more pharmacology content.